All of these are considered straight angles, which form a 180 degree. So we can take 63 plus x equals 180 to solve number 4. Then using algebra, we can move the 63 to the other side. These make 0. We're left with x on the left. And if we subtract, that gives us 117 for x. Solve the remaining 3 using a similar setup for your equation. For problems 1 and 2, record which angle pairs you think are congruent. So we can take a piece of tracing paper and we can check if 6 is congruent. We can rotate to see if 4 is congruent, or 8, or 7, maybe number 3. Oh, number 3 is congruent to number 2. Then we can check the next one, angle 1. Not congruent to number 2. It's too wide, but it is congruent to number 4. So number 1 is the same size as number 4. It doesn't appear to be the same size as number 8. It's too small, and it's too big for number 6. But 6 and 7 would be the same size. And 5 and 8 appear to be the same size. Did I trace it wrong? Yeah. There we go. Yep. Okay, over here we need to do the same sort of check. Here is angle 1. It's not the same as 2, but it is the same as 4. It also appears to be the same as 8 and angle 5. Let's check angle 2. Angle 2 is too small for 4, but it is the right size for number 3. It also appears to be the same size as 7 and 6. We are going to complete the angle relationship table as a class. These lines, N and P, were not parallel, but lines L and M were parallel. In problem 1, the only sets of angles that were the same are called vertical angles. Vertical angles are created when two lines intersect. these angles share a vertex, meaning a point at the center of the angle. Now we're going to write down the vertical angles. And that symbol in the middle stands for congruent. When lines are parallel, they also have vertical angles that are the same. Angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3. Angle 5 is congruent to angle 8. And angle 6 is congruent to angle 7, as seen with the highlights. In parallel lines, there are also other types of angles that are congruent or the same measure, and we call these corresponding angles. When two lines that are parallel are cut, this line that it cuts with is called a transversal. Angles on the same side of the transversal, so on the same side of that line that's cutting through, in corresponding positions are called corresponding angles. So I'm going to write that definition here in the description for you. And we will highlight them in the diagram. So 2 is on the right side above the line, and 6 is also on the right side of that transversal and above the line on its angle. 1 is to the left and above, and 5 is to the left and above. 4 is to the right and below, and 8 is to the right and below. 3 is to the left and below, and 7 is to the left and below. So we'll say angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. And angle 4 is congruent to angle 8. Now these are not the only types of angles that are congruent in parallel lines cut by the transversal. We see that the vertical angles exist, and there are other types as well. Make sure you have all the notes written down for this first part of the table. We also have lines cut by the transversal when parallel create what's called alternate interior angles. And when two lines are cut by the transversal, non-adjacent angles that lie in between the two lines, so inside of the parallel lines, and on opposite sides of the transversal, are called alternate interior. So interior, think of between the two lines, and alternate meaning opposite sides. So we will highlight those sets. Oops. Interior. 4 and 5 are alternate interior, and 3 and 6. So down here we will say angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. Another type is alternate exterior. So same thing, opposite sides of the transversal, but exterior meaning outside of those parallel lines. So when two lines are cut by a transversal, so two parallel lines cut by a transversal, non-adjacent angles, meaning not next to each other, that lie outside of the parallel lines and on opposite sides of the transversal are called alternate exterior angles. I'll add that description in for you as well. And then we will highlight those. We have exterior and opposite sides. Exterior and opposite sides. So angle 1 is congruent to angle 8, and angle 2 is congruent to angle 7. Take some time to make sure all of these notes are written down. Pause here if necessary to have more time to see these definitions. In the diagram, line R intersects parallel lines N and D, which means R is the transversal. If possible, find the measures of the remaining 7 angles. Write those measures on the diagram. We have a chart in part B as well that we're going to fill in related to these angles. So I see here that there is a straight line, and I know that straight angles are 180 degrees. We already have a piece that's 121 degrees, so whatever remains is going to be this angle over here, and that is 59. So 59 is this angle CBD, which also is a vertical angle with ABF. So this one is also 59. These two are vertical angles, so this is 121. We know that lines N and D are parallel, so 59 in this section corresponds to this angle because it's on the right side of the transversal and above the parallel line. 121 also corresponds to this angle because it's above and to the left of the transversal. This one we could say corresponds to this angle because it's to the left and below the parallel line. And this one corresponds here because it is to the right and below the parallel line. Now we're going to complete the table by writing the measurements of each angle from part A and provide an explanation of that angle's relationship to angle ABC, which is this one here. DBC is this angle here, and we know that that is 59 degrees because angle ABC and DBC form what's called straight angles. I believe on your page you can see the diagram and the chart at the same time. So instead of flipping back and forth, I'm just going to write out the definitions, or sorry, the explanations and the angle measures. DBF was 121 degrees, and that was because angle ABC and angle DBF are vertical angles. Angle FBA was 59 degrees, and that was because angle ABC and, ABC and FBA are vertical angles. Angle EFB was 121 degrees, and that was because angle ABC and angle EFB are corresponding. GFB was 59 degrees, and that was because angle DBC and angle GFB are corresponding. GFH was 121, and that's because angle DBF and angle GFB, or sorry, GFH, are corresponding. And EFH was 59 degrees, and that was because ABF, or FBA, and angle EFH are corresponding. Now it does say in relationship to ABC, so you could rewrite these in terms of how it's related to ABC, but you will eventually need to use some form of correspondence or alternate interior or alternate exterior to form other relationships as we go. So there are more than one correct answer to the explanations for how we got those angle measures. Use rigid motions to explain why each angle is congruent to ABC. So I'm going to flip back. We're looking for ABC and DBF. Those are these two angles shaded in red. And so if we were to take this angle and rotate it around point B, they would map to one another. I'm going to erase this so I can flip back and forth. If you need to, pause to write it down. Now we're looking for ABC to EFB. This would be a translation along B to F. And now we're looking for GFH. This one is going to require two motions. We're going to start by translating along BF, and then we're going to rotate around point F. In the diagram, FT intersects parallel lines EK and CR. So this line FT is the transversal. If possible, find the measures of the remaining 7 angles. Write those on the diagram. If it is not possible to find all 7 angle measures, explain why. Now, since they are parallel, and it tells us they are parallel, we know that there's corresponding angles, alternate interior and alternate exterior that we can use. I'm going to start with the vertical angles because those exist even when they are not parallel. So 71. I know this is a straight angle here, so I know 180 minus 71 would tell us how big CAT would be. And it is 109 degrees. And this angle is a vertical angle here, so this angle is also 109. This is a corresponding angle here, so that is 109. 71 corresponds with this one here. This 71 corresponds here, and this 109 is corresponding over here. So name all pairs of corresponding angles. CAT corresponds to ELA. TAR corresponds to ALK. CAL corresponds to ELF. LAR corresponds to FLK. Alternate interior, those would be inside the transversal, inside the parallel lines and opposite sides of the transversal, and these as well. So those are angles CAL, and it is an alternate interior angle with ALK. Then we also have LAR is an alternate interior angle with ELA. For alternate exterior, these are outside, so here, and then these as well. So we have angle CAT is an alternate exterior with FLK. Then we have angle TAR is an alternate exterior with ELF. In the diagram, the lines G, W, and A are shown. If possible, find the measures of the remaining 7 angles. Write those measures on the diagram. If it is not possible to find all 7 angle measures, explain why. So we know that 98 is a vertical angle here. We also know that the straight angle forms a 180-degree angle, and 98 is already taken up, leaving us with 82 for here, which is a vertical angle, creating an 82-degree angle here. Now, what it means by if not possible, it means just based on them being congruent, not with a protractor. We are not using a protractor for this lesson. So, the rest of them, it never stated that G and W were parallel lines, so we can't assume. We don't know, so we can't fill out this section because we have no angle measurements to go off of. Now, choose one angle that is congruent to angle VET. That is this angle here. And describe the rigid motion that would map it. The other angle that is congruent is SER. And the way that we would get from here to here is a rotation 180 degrees about that point E. What is the angle relationship between VET and ERY is this angle down here. So these two angles are both to the right side of the transversal and on top of the lines, which makes them corresponding. But corresponding angles are only equal in measure when we know for certain that those lines are parallel. Can you determine the measure of angle ERY? No, because we are not given that G and W were parallel. If it told us they were parallel, then it would also be 98 degrees. But it does not tell us whether they are parallel, so we do not know. Make sure your warm-up is finished, your workbook is filled in, and all of your diagrams are labeled with the angles that we can provide.